Okay, so the next couple lessons, we're going to talk about, well, we've sort of done some logarithmic equations, some pretty simple ones. We're going to talk about some ones that involve using the log laws to help you solve them. And then we're going to talk about exponential equations where we have to use logs and we have to use a calculator. Okay? Just to refresh your memory. Remember, this is the way a log looks. X, which is called the argument, I've said that before, has to be greater than 0. Has to be. The base of the log has to be greater than 0, and it can't be 1. So it can be a fraction between 0 and 1, and then it can't be 1, and then it can be something bigger than 1. And y can be anything. Y could be a fraction, y could be a negative number, okay? But just remember, and these are the restrictions, this is especially the restriction that we're going to look at. The argument has to be bigger than 0, okay? So we're going to look at a couple of equations, and these are equations that you would be able to solve without a calculator. One type of equation is you've got just logs on the same side of the equation. That's actually pretty straightforward because all you have to do is get a single log on each side, cancel out the logs, and solve what's left. This would be an example of that. Okay? But before we start, we have to state the restrictions or the non-permissible values. Remember, this has to be bigger than 0, right? What value of x or what values of x will make this greater than 0? Greater than -4. So when we solve, our answer has to be bigger than that. Otherwise, it's not an answer. So the nice thing about these ones is once you've got a single log on either side, just like we did with the exponential ones, cancel out the logs and solve what's left. What's x? Yeah, that's it. And that's a good solution because it's greater than -4. Now that's a very simple one. Okay, we'll take ones where you've actually got to use the log laws to make a single log on either side. The other type is you've got a log on one side, you've got a constant on the other. When you get into a situation like that, change it to exponential form. Okay? First, so this one, we're trying to figure out what x is. Well, what's the restriction on x? X has to be greater than 0. And now change this to an exponent. What does it become? 2 cubed equals x. Well, that's pretty easy. X equals 8. Okay? And we're done. Okay. C. For this one, x has to be greater than 0. For this one, x has to be greater than what? 3. So what's the restriction? It's always the higher number. So the restriction is it has to be greater than 3. Okay, always take the higher one. And now, notice I've got logs and a constant. So what I need to do is I need to make a single log on this side. Well, when we add 2 logs, What do I do with the arguments to make it into a single? It's one of the log laws. When you add, you multiply. So it's going to look like this. Now we change it to an exponent because we've got a single log. Well, what's the base? Remember, if there's no base, it's 10. So it's going to be 10 to the first equals x times x minus 3. Well, that's actually a quadratic equation. 10 to the first is 10, and if I multiply these out, I get this. So how do I solve a quadratic equation? I got to get everything to one side and factor. So I'm going to bring the 10 over here since these are already there. Minus 10. That's a trinomial that can be factored to 1. Minus 5 plus 2. Therefore, my solutions are, but here's where you got to be careful. Is one of those a restriction? Yes, because the numbers are good as long as they're greater than 3. That's out. This one is the first type. First of all, what's going to be the restriction? Right, it's x greater than negative 2 here, it's x greater than 3 here, but I got to take the higher one. Notice I've got all logs, so what I need to do is make a single log on either side so I can cross out the logs. So this becomes what? Divided by x minus 3 equals log 4x. 6, pardon me. Now I can cross out the logs. And I am left with x plus 2 over x minus 3, and I'm just going to put parentheses around those to remind myself they have to stay together. How do we solve this one? Clear the fraction by multiplying by x minus 3. X minus 3. So those go, and I'm left with x plus 2 equals 6x minus 18. No squared, so I don't have to worry about factoring. It's just a straightforward equation. So I'll take the 6x over here, becomes minus 5x plus 2 equals negative 18. Subtract 2 from both sides. Divide both sides by negative 5, and I get 4. Double check to make sure it's good. Yes. Okay. Okay, couple minutes. Is this logs and a constant or all logs? Logs and a constant. So what I should do, well, first of all, what are the descriptions? Greater than negative 2. I should take the minus 1 over there and the log 50 over there. right? Because you got to get the logs together, and then you got to get the constant by itself. So if I do that, I'm going to get log x plus 2 minus log 50 equals positive 1. This compresses into a single log, and subtraction becomes division. What's the base? N. So what does this look like now? Because now I've got a single log and a constant. Now I've got to change it to exponent form. N to the 1 equals x plus 2 over 50. Well, 10 to the 1 is just 10. Multiplied by 50. And I get 500 is equal to x plus 2. Therefore, x is 498. Restrictions. X has to be, well, there's only one x here, greater than 0. All logs, so I got to get these two together. Well, the first thing I have to do is use my power of a power log law to put the coefficients of these two as exponents. So I get log 4, 2 to the 4th, minus log 4, 4 to the 1/2, equals log 4x. Well, what's an easier way to say 2 to the 4th? 16, right? What's an easier way to say 4 to the 1/2? 2, because you square root it. And now, since we're subtracting, to write this as a single log, isn't it 16 divided 2? Which is just 8. Single log on either side, cross them out. Well, that's easy. X equals 8. That's it. Okay. But you can see these would all be non-calculator questions. Okay. Except for the last one. This one would have to be a calculator question. But this one, this was on an old provincial exam. What the heck do we do with this? Any ideas? Sorry? But there's no log here. I can't put it in front. Like, even though this has a log in it, it's in exponent form, right? So can't I put this in log form? So this would be log base 7, okay, of x, yes, equals, sorry, I got myself confused there for a second, log base 7 of 2. Well, we got a single log on either side, cross them out, x equals 2. That is a bit of a tricky one. It's a bit of a challenge. Okay. But yeah, if you get stuck on something, try changing the form. See if that helps. Now this one, you may want to do this, change it to exponent form, but 5 to the what is 40? I can't do that in my head. That's some decimal number. Okay. Can you think of another way that you could do it? Yeah, can't we just calculate from here? Using the change of base, log base 5 of 40 is the same as the log of 40 divided by the log of 5. And that's going to give you a decimal answer. Okay. So that we had to use the change of base theorem. Anybody happen to get it? 3 decimal places, 2.291? 2. Thank you. Okay. And that's sort of the next step is we're actually going to start tackling ones like this, where we can't do them mentally. We can't do them in our head. Okay, we need a calculator to assist us. We'll talk about that next time.